Alright guys, here we go with the review for the structures test. Number one, where does BC intersect plane, the line BC intersect plane P? So very clearly here you see the line BC. Here you have plane P, and of course BC is intended to be going vertical up and down. The plane is kind of flat. So where they intersect is right there, and that would be point A. Excuse me. Where does BH intersect plane P? Well, again, in blue there you have the plane, but here's line BH in green, hopefully, or not. Alright, I don't know what's going on there. This pen doesn't want to work. So we'll try that again. Here in green, you'll see line BH. There's the plane in blue. Are they intersecting each other? They are not. So the best answer you have here is they don't. Name two lines that pass through point C. Well, very clearly in red here from that first question you have line BC. So you have that. But then it looks like in the picture there's no other lines that go through C. But if you remember back to when we first started talking about points, lines, and planes, just because it's not drawn there doesn't mean it does not exist. So you could also, I'm going to go back and erase some of the colored pen stuff I have up here to kind of clear it out a bit. Any 2 points anywhere on a plane in space will make a line. So just because they're not drawn, you could also have FC, and you could also have HC, which look like they're parallel. I don't know if they would be or not specifically, but the point is that they would also make a line. Sorry. Even though they're not drawn, they could create a line and therefore pass through point C. That's FC and HC. So those are possibilities, okay? All right. Use the following pictures for 4 and 5. Name 3 segments that are coplanar to EG. So EG, if you make the segment, is this diagonal that goes there to there, which means it's on this bottom plane. So any segment that's a part of that plane will work as coplanar. So there's multiple choices: FE, FG, GH, EH, and then don't forget also the other diagonal that isn't drawn again but still works, FH. Now I know it only said 3, but any of those will work, and they're all on the same plane. Name 4 coplanar points. So there's a lot of possibilities here. Again, I'm going to go back and erase some of the colored pen up here, but when you have a box like this, or a rectangular prism, every face will be considered a plane. So that's a plane. That's a plane. That's a plane. In the back, and then top and bottom. I'm not going to go through all of them. So really, any set of 4 points that kind of make up that would be considered coplanar. So a lot of possibilities here. Understand the idea of what they could be. So I could have TS, EF. I could have points UR, GH. I could have, you could also have points E, F, G, H, and those are just a couple. There's obviously each face has a possibility, but coplanar, just all in the same plane. All right, so we come over here, number 6. G is the midpoint of HF, J is the midpoint of HG, JG is 20. So draw the picture. Here's a big segment. G is the midpoint of HF. Oh, sorry, got that wrong. G, not J yet. And so HG and GF are the same length because it's a midpoint. And then J is the midpoint of HG. That's a phone. Hold on. Wrong number. As I was saying, J is the midpoint here. So we haven't really talked about these much, but one of the symbols they utilize to tell you that things are congruent in length is a dash. So the dash here and here tell you that those segments are the same. And then since we're having new, smaller segments or different segments, they have to add the dash, just like the curve and the angles. So JG is 20, so now back to the whole thing. Now, if that's 20, then that's 20. So we know from here to here is 40. And then since that's a half, or midpoint, that's cut in half, that's 40. So what should be the full length? Oh, okay. That's fun. Let's try that again. So what should be the length of HF is 40 plus 40, which is, of course, 80. It's a messy 80. Number 7, y is the midpoint of xz. Which of the following must be true? So you have x, y, z, and again it's a midpoint, so there's the dash. Is it true, number 1, yz is equal to half xz? Here's yz. Is that the same as this cut in half? Yeah, that's a midpoint. True. Is 1/2 of xz, so again, half of xz equal to 2xy's? 2 of these? No, because xy is a half. So if xy is half of xz, it's not the same as 2 of itself, right? So 1 of itself does not equal 2 of itself. That makes no sense. And number 3, 2xy's. So again, here's xy's, but 2 of them would make a whole line. Is that equal to xz? Yes, it is. So true, false, true. Name 3 different ways to write the segment addition postulate. So segment addition postulate just says the smaller segments that are combined add up to make the bigger one. So you could do VW plus WZ, equals VZ. Basically, it's different ways to write that the smaller segments equal the bigger one. You could do VW plus WX plus XZ equals VZ. So this time, instead of doing like what looks like 2 halves, I did this plus this, and then I made that 1. Still segments, still add up to the big thing, just a different combination of them in order. And then if you want, the last thing, or one of the last ones you could probably write is just all of them together. VW plus WX plus XY plus YZ equals XZ, which is this segment plus this segment plus this plus this. Literally all of them individual. And the last one here, or almost the last one, last couple here. What is the measure of CD? Right, pretty simple. It's literally what we've all been doing here. C to E is 34 inches, F to D is 12 inches, CD is this whole thing. So 34 plus 12 equals 46. Find the measure of LM. So this time we have the whole thing. We don't know what LM is. We know MN is 22. So this is subtraction. And that's 90. So real simple. All right, so this video will continue on page 2. Good luck. All right, here we are on the back page. We'll finish this up real quick. Hopefully it won't take too long. Give me just a second to make sure this is ready. Yeah. All right, so number 11, if G is the midpoint of HK, what is the length of HG? So again, if this is a midpoint, this and this should be the same. Yes, literally as easy as you think. Don't overthink things. Half 110 feet. 12. So notice the letters are out of order. And in fact, on the previous problems, the letter the letters are out of order here. But since they're given to you and they're part of the picture, it's okay. You just got to go with what they give you. So AC is 3x plus 5. BC is 2x. And the whole thing is 55 from A to B. So they want to know, what equation should you write? Well, you're going to take AC plus CB, and it should equal, I just realized I wrote 5, didn't I? 55. So to solve for x, you're going to combine like terms, 3x and 2x. 5x plus 5 equals 55. Minus 5, 5x equals 50. Divide by 5. X equals 10. Now that x is 10 for AC, you're going to plug in 3x times 5, but now that x we know is 10. So you're going to plug in 10. 3 times 5 is 30, plus 5 is 35. And then your paper originally says AB, but we already know what AB is, so it should have been BC because that's the other one. And BC will be 2 times x, so 2 times 10, which is just 20. And 20 plus 35 gives you 55, which is the whole thing. All right, finishing these off with midpoint distance and so find the distance between points C and D. We need to determine where are C and D located on the grid. So C is at -2, -1. D is at positive 1, 2, 3, 4, 5. Yeah, this pen is not working really well today. It's making me write worse than I normally do, which is saying something. Let's just try that over again. So D is at positive 5, 1, 2, 3, 4, 5. Down 1, 2, 3, 4. So I want to find this as a distance. I'm going to use distance formula. Big square root, parentheses. Now, if you need it, that's x1, y1, x2, y2. So I start with x2 minus x1. 5 minus -2 squared plus y2 minus y1. -4 minus 1. -1, sorry. So both of these become plus plus. 5. All right, sorry. So there is someone down the hallway. So, yeah. I'm actually making this during fourth period conference on Monday. So now you know. So 5 plus 2 is 7. Negative 4 plus 1 is going to give you negative 3. So 7 squared, positive 49. Negative 3 squared, 9. Move over a bit. 49 plus 9 is 58. It's not a whole square. It's not a whole number square root, and you don't have your calculator, so leave it like that. What is the midpoints of A and C? A is located at negative 3, 1. And C is located again at negative 2, negative 1. This formula a little bit easier. You have x1 plus x2 divided by 2 for the x's, and you have y1 plus y2 y2 is the number negative 1 divided by 2. So negative 3 plus 2 will give you negative 5. One plus negative 1 is 0. And I mean, that's pretty much your answer. You need to divide. You can leave negative 5 halves or make it negative 2.5, and the other one is 0. And there you go. So last one, I should have done this in class with everybody, but of course I'll do it here in case you were gone or just in general. So find the coordinate that is 4/5 the distance from A to B. A is located at negative 3, 1. And B is located, let me go back and look at B, 4, 4. So the only difference between this with 2 points, with a point, I should say, as opposed to just numbers, is you have to do it twice. We're going to have to do that formula for fractional distance for x coordinates and then for y. So let me go through first for the x. You're going to take the fraction, multiply it by the distance from the negative 3 to 4, the x1 to the x2. We find distance by subtraction, doesn't technically matter what order. That becomes plus, and I have 4/5 times 7. Put that over 1. 4 times 7 is 28. 5 times 1 is 5. You have to take that value and add it with x1, the negative 3. So when you're adding fractions, you can't use different denominators. So I'm going to multiply this as 5 over 5. And that's going to give me negative 15 over 5 plus 28, can't make the loop, over 5. Which with different signs, 28 minus 15 is positive 13 over 5. You can use that as your answer. We'll get back to that in a second. Then you got to do the same thing for the y's, y1 and y2. So the fraction times the distance, but this time we're using the y's. How far is it from 4 to 1? Well, that's only 3. So when you multiply that, you put that over 1. 4 times 3 is 12. 5 times 1 is 5. You're going to add that to y1. y1 is just 1. So 1 over 1 plus 12 over 5. Again, can't do that unless you make this a denominator of 5. But because that's 1, that means that we're just going to actually get 5 over 5 here plus 12 over 5. And that equals 17 over 5. So your answer is the point 13 over 5, 17 over 5. And that's it. Not as difficult as you think. All right, so good luck. There should be the test tomorrow, and we'll see how that goes.